Today we're going to learn about lists. So, what's a list? Surprise, a list is a list of items. Actually, we've kind of used lists before. If you remember, a string is what's called a sequence data type, and a sequence is just an ordered set. A list is also a sequence data type. It's more general than a string. Instead of a list of letters, it can hold almost anything. Let's start by making a list. To create one, make a pair of square brackets. Obviously, this list has nothing in it, but you can add values and separate them with commas. These values can be any of the types we've been using. Here I use strings, but you can also make a list of integers, floats, and booleans. You can even make lists with more than one type of data, or a list made up of other lists. Nesting. Hold on though, we'll get there. The idea is that a list can hold different things. They can also hold data types that we make ourselves, which we'll get to in the objects unit. You should know that all of the values in a list are ordered. The first value is at index 0, this one at index 1, this one at 2, and so on. Remember, it starts from 0, not 1. This is because it makes it easier for us to perform operations on sequences. So, what can you do with a list? Well, you can print it, but that's not super useful. If you remember back to Unit 1, we can use those same sequence operators that we used on strings. Calling len will return the length of the list, and we can use those slicing operators to get a certain value in the list or a segment of the list. If you forgot, this is how you get a single item, and this is how you get a segment between two indexes. A colon before or after marks the beginning or end of a segment. You can also use negative numbers as indexes, and it'll count from the end of the list. You can also add lists together and multiply by an integer to repeat them. These operators return a list or item. They don't actually change the original variable. I can perform all of these operations and then print out the variable and see that everything is unchanged. If you want to change the variable, you have to set the original list to the new one. So in this case, set x equal to the result. However, the following operations do modify the original list, and most of them do not return a value. To change the value of one specific item in the list, select it using brackets, then use the equal sign to assign the new value. You can also replace whole segments of a list with a new list, using the same bracket selectors. You can add on an item to the end of a list using the append command, and put the item you want to store inside of the parentheses as an argument. Use the insert command to add an item at a specific point in the list. It'll put the item in the index you specified and push all of the other items in the list down by 1. The remove command will remove the first item in the list that equals what you specified. If an item is not in the list, this command will throw an error. So if you don't want errors, you can use the keyword in to check if the value is actually an item in the list. This will evaluate to true or false. You can say, if item in list, remove the item. That looks like this. The clear command will remove all of the items in the list, so it becomes empty. The index command will find the index of the item you give it and return that. If you give it a value that is not inside of the list, it'll throw an error. The pop command is sort of like the remove command. However, instead of the exact item to remove, you give it an index. So you can remove the second, or the fifth, or the eighth, or whatever item you choose. It will also return the value that it removed, so it's easy to store or print out. We'll talk about why indexing is important when we combine lists with loops. The count command takes one value and will return how many of those are inside of the list. The reverse command will reverse the order of the list. The sort command will sort all of the items in the order from smallest to largest. It's built using the comparison operators, so it checks which items are larger using greater than and less than. If you have a list of numbers, it'll be sorted from lowest to highest, and if you have a list of strings, it'll be sorted alphabetically. So that's about all of the list operators in Python. But you have to know one small thing to avoid problems in your programs. Here's a small program. I want you to guess what we'll print out. Pause and take a few seconds to walk through the program. It seems pretty simple, right? The output should be apple, banana because the variable y was assigned the value of variable x and was not changed since it was printed out. When we run this program, you'll see that somehow caret printed out. So how did that happen? It's because a list is what's called a reference type. Here's what really happened in this program. So first, we created a variable called x, which stored the two items, apple and banana. So in memory, we create a space that will hold these values, and when we call x in our program, it'll give us this value in memory. That all makes sense. When we create the variable y, we assign it to x, so you'd think that, in memory, a new space is created and all of the values of x is copied into the space for variable y, right? Not exactly. Y is actually assigned the location or address of the value x. Nothing is actually copied. So calling y does not return the value of y, but where it points to. Calling y will actually return x. But why does that happen? If x was any other types we learned, like a string or number, the value would be copied. They would be independent, not the same. Well, the problem with lists is that they have the potential to be very, very large. A single list can contain hundreds or more values, so if you want to copy the value, it would be an enormous strain on your computer. Your program would be super slow, so simply pointing to the real value is a lot easier. So going back to this program, how do we get it to print the output we want? How do we make the two variables independent? To do so, you must force Python to copy the list, instead of making a reference to it. Instead of setting y to x, I'll say y equals x.copy. This command actually copies the list item by item, instead of referencing the first one. If I run this program again, we finally get the desired output. Awesome! So that's all for this lesson, but stay tuned, because in the following videos, we're going to use the true power of lists. Code Dug out.